All right, let's get started. Good afternoon, everybody. Welcome to this month's webinar on Showcase of Open Source Tools in Medical Imaging. My name is Brad Generu, and I will be serving as the moderator for today's webinar. We are at an exciting juncture in 2017. People around the world are working on innovative, dynamic, open source projects to solve all sorts of challenges. This has not been lost in the medical imaging space, where there are tools to handle working with images themselves, imaging metadata, and various clinical workflows. Today, we will be looking at 4 open source tools that you can use to explore imaging in your world. These tools help unlock medical imaging to those less familiar with the classical technologies of DICOM and HL7 and bring these to the forefront of today's modern ecosystem. In addition to engaging in Q&A through the chat feature of this webinar, there will be a live tweet chat. Please be sure to use hashtag ImagingIT to engage in this online conversation or to tweet your questions. We are really privileged today to have a great group of panelists for today's webinar. Our first speaker is Chris Hafey, Chief Technology Officer of Nucleus Health. He will be showcasing Cornerstone and Open Health Imaging Foundation technologies to display interactive medical images on the web. Next up will be Frederic Lambrecht, Chief Executive Officer of Ozimus, who will speak about the Orthang project, an open source lightweight DICOM server. Third up will be Christian Knapp, Lead Developer for Spark at Fior. Spark is a reference implementation of HL7's FHIR standard used for the communication of medical information. Lastly, we'll have Dr. Judy Gachoya from the Indiana University School of Medicine, who will be speaking about LibreHealth, an open source electronic health record system. These open source projects are all connected to SIIM and the SIIM Hackathon. The SIIM Hackathon is an event taking place as part of SIIM 2017, where like-minded informaticists and developers come to learn about and build interfaces that are changing the way health information systems work, communicate, and interact with each other. It is a great space to experience firsthand how new and experienced coders build and test applications, collaborate on projects, and develop the next generation of applications and utilities. The SIIM Hackathon have featured these 4 open source projects we're speaking about today, both as part of a repertoire of tools, in the case of Spark, Orthang, and Cornerstone, or integrated into other open source projects like LibreHealth. Today's panelists are heroes in the open source medical imaging space, and we're really privileged to have them share their respective projects and perspectives today. With that, I will now turn things over to Chris Hafey to begin the presentations. Welcome, Chris.
Thank you, Brad. Hi, everyone. My name is Chris Hafey. I am the Chief Technology Officer for Nucleus Health. It's my pleasure to discuss Open Health Imaging Foundation and Cornerstone with you today. There's basically 4 parts of my presentation. I want to give a quick overview of OHIF and Cornerstone, a lot of demos about software we have working today, walk through the architecture of what I showed you, and also a slide on learning more, so how you can actually understand more about it. So first of all, Open Health Imaging Foundation is a 501c3 nonprofit organization that was formed to really advance open source healthcare medical imaging. We have a number of different libraries and I would say products that you can actually use today that have actually been under development for the last 2 to 3 years. One of the key things that's a OHIF, also pronounced OHIF as an abbreviation, is we're really focused on new technologies, new modern web technologies, specifically around zero footprint web display, JavaScript, CSS, HTML5, so no Java or Adobe Flash or anything dependencies, just pure modern web technology. Number 2 is it's 100% free for any use, including commercial use. And so all the software is licensed with the MIT license, and there's many companies that have actually taken this and commercialized products on top of this technology. One of the key things about OHIF is that it has an extremely active community. There's over 371 GitHub stars. We estimate 1,000+ users out there, and several commercial products built upon this technology. So again, very much using modern technology, very active community, very focused on JavaScript enabling of medical imaging technology. So with that as a foundation, I'm going to actually go through a number of demos. First, I'm going to the OHIF website, so ohif.org. You can check this out on your own. There's a button up here called Demo. and it'll actually launch our zero footprint web viewer. So this is an example of querying the study work list running on Orthonc server. So there's a discussion on Orthonc later on. If I want to look at a CT study, I just double click it, and you can see it spawns it, and the images download very rapidly. You can actually see that the reference lines come up. I can actually do things like zoom in and adjust the window level brightness. This is all leveraging JavaScript, HTML, and CSS. So in this case, there's a DICOM web server behind it, and I'll talk about more of that later on the architecture. But there's a DICOM web server that's serving up the images over WADO and being displayed on the client. And essentially what you have here is IHE basic image review type capability. This is a full zero footprint web viewer, 100% open source, with all the source code out there. Underneath this viewer is actually a couple of key libraries. One is called Cornerstone, and so this is an example. Actually, I'll go back to the web viewer. Anytime you see an image display, that's using a library called Cornerstone. Cornerstone was designed to allow you to very easily take a DICOM image, display it on a web browser just as easy as you could a JPEG or a PNG image. Obviously, the web browsers don't support DICOM today, so that isn't possible. So the Cornerstone library fills that gap by making it very easy to build your own custom web-based applications as a JavaScript developer. So anytime you see an image, that's Cornerstone. If I change this to other tab, this is an example of how you can actually display a DICOM Part10 image when read from the local file system. So this black box here will display the image when I drag it over in a second. And over here, you'll see it dump a bunch of the attributes about the image. So if I come over to my my file system browser, I can drag the CT image. This is actually some sample images provided by David Clooney in the DICOM, one of the DICOM working groups. This is JPEG LS, which is my favorite transfer syntax. And all I need to do is just drag it over, if I can actually drag here, there we go, onto the web browser. And what it does is it actually loads that DICOM Part10 image off of the file systems. This is a drag and drop operation. There's no server involved in what I'm showing you here. Everything's running in the web browser. It decoded the image using JPEG LS, transfer syntax decompression codec, just parsed out the DICOM attributes and displayed the image here. So this is all done in the web browser without a server. And so you think about the promise of DICOM Web really making it much easier to access medical imaging data from a web browser. This is a technology that paired up with DICOM Web can make it really easy to do so, especially for developers that want to display, have their own web-based apps. Whether you are a vendor or provider, you have your own web-based app system out there, you can very easily drop in Cornerstone and image enable it with DICOM imaging. The other demo I want to show you is a really handy utility for anyone involved in medical imaging informatics, and this is a DICOM dump utility that's available on the web. And the nice thing about this is that it loads into your web browser. Actually, this and the prior tool, you can see, me as a developer, I've often needed to very quickly look at a DICOM file. This is a really nice way of just dragging and dropping it and seeing what it looks like. To go to the next level, if you want to look at all of the DICOM attributes, you can do the same thing. So as long as you have a web browser, if you have a DICOM file, I can take it and we're having trouble dragging today. Sheesh. My apologies. There we go. I dragged that file over here, and what it did is it parsed the DICOM header and displayed all the attributes here. This is, again, a fantastic tool for developers, IT folks, anyone that want to very quickly look at it. You'll see that the default display shows the DICOM attribute and the value. I can do all sorts of interesting things here. I can actually show the group and element. I can show the VR, and I'll actually reparse it. One interesting thing for those more technical, if you want to look at the fragments and frames in a compressed image or multi-frame, you can do that. And so in this case, the pixel data shows each individual fragment. This is a very technical DICOM piece, but it's a really nice feature, especially if you're looking at that level of detail. So this tool is available all the time. It's something all you need is a web browser, a modern web browser, and you can actually do a DICOM dump and no need to install any software. Very, very handy. So that's the end of my demos. I want to walk through a little bit about the architecture behind what you just saw. So first of all, in terms of the OHF viewer, here is the example of a physician or user, patient, any user. All they need is a web browser. So modern web browser, whether it's Firefox, Chrome, Safari, any modern HTML5 web browser will work. And it downloads, the bulk of what you see is actually running in the client. We actually do provide a very small OHI viewer server, which does a few things. It's very lightweight, but the key thing is it talks to a DICOM web server. So in this case, it's talking to Orthonc. We've also tested against DCM for Chain, another open source product, and also a couple of commercial products, and it works quite well. Everything is over HTTPS communication. Again, no plugins, but this is really what you saw. The end user talks to the web browser, which talks to a very thin server, which talks to the DICOM web server over Keto-RS and Wado-RS. In terms of the client architecture, a couple of different layers here. So working from the bottom up, we talked about the DICOM parser. I showed you the example where I put a DICOM part10 file in it and it parsed the header. That's fundamental. Before I can work with DICOM part10, I have to be able to parse it. So that's what the DICOM parser does. Again, this is a pure JavaScript library. It does run in the browser, but it also runs in Node.js. And so if you have a Node.js-based backend architecture and you need to parse DICOM, this does it quite well. It's very, very, very quick and easy to use. Building on top of DICOM parser is the Cornerstone libraries. And again, the Cornerstone libraries I showed you, it makes it easy to take a DICOM part10 image and display it on a web page using an HTML5 web browser. I'll have another slide going into more detail on that in a second. Building on top of Cornerstone is a library called ViewerBase. This is an OHIF library that really makes it easy for you to build your own zero-footprint web viewer. So while Cornerstone solves a very important problem in DICOM parser about displaying an image, there's a lot more involved in building a full viewer. You have to deal with laying out multiple images. You have to have a thumbnail viewer. You have to have tools and all these kind of things. That's what ViewerBase does. On top of ViewerBase are actually two viewers. Again, these are all open source. One's called OHIF Viewer, and one's called Lesion Tracker. The OHIF Viewer is what I showed you. It's a kind of equivalent to a very basic IHE basic image review type viewer, something that you would expose through the EMR. Lesion Tracker is actually a more advanced viewer built for clinical trials management by the Precision Imaging Metrics team at Dana-Farber, and they are building on top of this as well. A little bit lower behind the scenes in terms of Cornerstone architecture, it's actually a very, very modular architecture that allows you to use what you need and not pay for what you don't want to. So at the kind of center of the world is a Cornerstone library, otherwise called Cornerstone Core. And then over it, you'll see two different loaders. One's called a Wado image loader, and one's called a web image loader. The Wado image loader allows you to connect to DICOM web and Wado URI archives. And so if you have a VNA or a PAX that supports the old Wado URI or the more modern DICOM web, you can very easily connect to it and load images to display in Cornerstone, just like I showed you. Again, for DICOM part10, there is the DICOM parser library, so you can see how Wado image loader depends on DICOM parser. For the web image loader, this allows you to view non-DICOM images like JPEGs and PNGs in Cornerstone. Finally, there's a whole tools library which allows you to do things like measurements and window level adjustments and scroll that has also computational geometry library too associated with it. You can use as much of all this or as little as you want, and it's been used, like I said, for research projects, student projects, commercial applications, and prototypes. It's fantastic. People find it really easy to use. In terms of some of the key features, just to enumerate them really quickly, one I want to call out is that it decodes all modern DICOM transfer syntaxes. This includes JPEG 2000, JPEG LS, JPEG lossless, RLE, all of them. We can't display non-DICOM images. We even support nonlinear VOI modality LUTs, non-square pixels. In terms of the actual viewer itself, we actually even support hanging protocols and full DICOM web support, and also mobile and touch support. Want to learn more? A few opportunities. At the SIIM annual meeting, there's actually a learning lab where you learn to build your own zero-footprint web viewer. We'll go into detail about how to use the libraries in a hands-on manner. You can go to the OHIF website to learn more about what our mission is and who's involved. If you want to look at the actual code and get your hands with it, just use Google. Search for Cornerstone GitHub or OHIF GitHub and you'll find it. Finally, there is a Google group called Cornerstone Platform where the community will talk about features, bugs, how to use it, and there's actually very active support for it. So please come join it and read and ask questions if you have it. That concludes my presentation. The next one is Frederick Lamberch, the CEO from Osimus on Orthonc. Thank you.
Thanks, Chris, for introducing me. I'll be speaking about Orthonc. So Orthonc is an open source reference implementation of the DICOM standard, and I'll be speaking in instead of Sébastien Jadon, who is the creator of ORTANK. This presentation will be done in 3 parts. One part about the origin and philosophy of ORTANK. Then I'll be displaying some of the features and the use cases that ORTANK has been used in so far. And then lastly, I'll be highlighting one of the elements in the roadmap on ORTANK's roadmap, which is the implementation of the supplement 145 of the DICOM standard. It concerns whole slide imaging. So ORTANK was created in Belgium in the University Hospital of Liège by Sébastien Jadon. The initial issue he was solving back in 2011 is the fact that he needed to transfer medical images from the radiology department to the radiotherapy department. And as he started building that solution, he asked his hierarchy to open source this solution, and he gradually built actually a full-blown DICOM server that has, in the meantime, been downloaded over 100,000 times worldwide, and was since awarded by the Free Software Foundation in 2015. So here are the features of ORTANK. It is a DICOM server that is actually very lightweight, so it doesn't require much power or infrastructure to run. It can actually run on a Raspberry Pi. It can run on a Mac, on a computer, on a PC, sorry, or on a Linux. It can even run full cloud applications. It has a REST API on all the features that run in ORTANK, so you can basically drive ORTANK through any other application. It is very extensible in the sense that it can have plugins. So the core of ORTANK is GPL, and then it has AGPL plugins that can serve for a specific type of storage, but also viewers. And one of the viewer plugins is the Cornerstone implementation within ORTANK. And then there are some other plugins that will serve, that I'll talk about later, one of them at least. It has been 100% virtualized, so it's been Dockerized, so it can run as a microservice. You can use a specific feature of ORTANK in any instance that you launch. So you can use one instance for viewing, another one for storing, and yet another one for being a router or something. It is 100% standalone, which means it has a SQLite server burnt in, and it can then hence be 100% autonomous, and it has an SDK, so you can extend it by yourself. Basically, ORTANK is a mix of a PAX and a VNA, but it's also a toolkit, a DICOM toolkit, and it has been fully web-enabled. So it's a kind of a deconstructed PAX, if you will, that has it's a bit of a Swift knife. It has most of the features of a PAX and a VNA. It has all the features of a DICOM toolkit, and thanks to its web-enabled technology, it can run in the cloud, and it really enables sharing and integration with other applications. I'll now run through a series of use cases, the first of which is a basic clinic implementation where ORTANK can run as a PAX. It's been done in hundreds of hospitals across the world, mostly in lower income countries. This is a setup that we've basically created at Osimis. So Osimis is the commercial company that runs solutions with mostly ORTANK inside. It basically now enables a hospital to send off DICOM studies to another hospital, and the receiving hospital will basically reconcile the patient in the patient health record, scratch the patient ID in the study, and then store it in a PAX. This is a vendor-neutral archive solution where multiple hospitals basically store and archive the residue of their storage in a centrally located database. This is a setup that was set up in France in a group of 75 hospitals in the south of France, where OrtHank runs as a distant viewing solution. This is a solution where a review board has been set up in multiple places in France as well and in Germany, where basically studies are shared. They're duplicated from one PACS to another PACS that is located in a central location, and we use the DICOM web implementation in order to do this transfer. OrtHank is running in many web applications where it can basically be used as a separate library to store and visualize medical images. So my last part of my presentation, we'll talk about whole slide images. So the problem that we currently have with whole slide images is that the scanners that are sold by the vendors are mostly proprietary. They produce files that are in proprietary storage formats, and they sell proprietary viewing software that comes along with it. And because of that, these files are stored in isolated file servers that are not connected to the rest of the hospital. So the solution could well lie in DICOMizing those images, which comes with a few challenges, but the advantage of doing this is that any PACS can store this kind of files, and it can then be integrated in the workflows of the hospital through the DICOM work list. So a RIS would then become a list, so a lab information system, and the structured reports could be used in order to track the annotations and the interpretations. So what the Simple Stage has done and integrated in OrtHank through a plugin basically holds two features. The first one is to DICOMize all the whole slides, basically using the open slide implementation of proprietary formats. So he parses the image through open slide and then stores it under the DICOM format. This is the first feature of the plugin. The second feature is the fact that it comes with a viewer. So once it's DICOMized, well, it's nice, but you also need to view it. So we've got this viewer running. It basically runs in the cloud, in a web browser, any web browser, basically like a bit like Chris Hafey's Cornerstone viewer. And this is then another use case. It is going to be used very soon in a network of digital pathology hospitals. Well, basically hospitals that do digital pathology and have to use this platform in order to be able to share digital pathology images. So as a conclusion, OrtHank can handle 100% of the medical imaging scope. So that's radiology, but also video and DICOMized video and DICOMized JPEGs or whatever standard file types. And lastly, ANAPAT, so digital pathology. I thank you for listening to me. If you want to know more about OrtHank, just surf to orthankserver.com, or you can tweet about us at orthankserver. I'll now, next up is Christian Knapp, who will be speaking on behalf of Furore. It's an open source reference implementation of the HL7 FHIR standard.
Thank you very much, Frederik. Indeed, I will be talking about Spark and Vonk. I will get to the latter on the latest slides of the presentation. First, a short introduction about who we are. We are Furore. We are a healthcare IT company based in Amsterdam. And we have been with FHIR since the very beginning. Also because Ewout Kramer is one of the three founders of the HL7 standard FHIR. And he's one of us. We're very .NET focused, Microsoft.NET, so that's what our tooling is based upon. I'm a developer, architect, analyst, whatever you need, at Furore for quite a while now. and I've been involved with FIRE since 2012. I understood that most of you will probably already have heard of FIRE, but I'll introduce it shortly nonetheless. It is a new HL7 draft standard. It's still a draft. And it started back in 2011. It's very modern. It's based on web standards. You can exchange health information based on REST, so just like URLs in your browser, getting XML and or JSON back, which makes it very easy to build web applications, single-page applications, etc. It is still very well modeled. All the experience that has gone into the previous versions of HL7 has been used where possible. And there are very distinct resources like patient observation, questionnaire, etc. All these resources that you can communicate about are extensible from the start out. How you can extend them is also standardized and in a computable form. And it's not just computable, it's also checked for implementability. And that's part of where Spark comes in. We took the task of implementing a FIRE server in .NET. First to see whether all that was architected in the specification could actually be coded in source code. Apart from that, this has also been done in Java and in Delphi. Well, we do all kinds of things with FIRE. We built the FIRE.NET API, which is a library which you can use to build your own FIRE client. It has been used for that in many occasions as well. You can just download the code and use it, or you can use the NuGet packages. We also built Forge. I said the standard is extensible by design. That extensibility is not trivial, so you'll need a tool to do so, and Forge is the tool to do so. If you have made changes to the standard or extended it, you have created a profile and you can register it on our platform SimplifierNet so others can find it and reuse it. Well, obviously we built Spark. And we also built Vonk, an enterprise successor to Spark. Not the least is that we do FIRE Developer Days every year in November, so you can join them to learn about FIRE. Why do we need a FIRE server? Well, the FIRE standard had the intention to make it very, very simple to create a client. You can just do a few REST calls, get the resources back, and then, for example, in JSON, and then show them. Or if you have an imaging device and you want to send the metadata to someone else, you create a resource that contains that and send it over an HTTP interface. On the other hand, the standard also defines complex operations like searching on the various types of resources, which can also be interconnected, just like joins in a database, and preserving history and calling for history or changes throughout the system, and other more complex operations. Well, to do that, all that complexity has been moved to the FIRE server. So there are a few applications that handle all the complex work, so all the clients can be simple. Well, Spark handles that for you. That's why we have a server. So it's a RESTful web server. It can store resources of any type. There are, I believe, like 120 different resource types in FIRE currently. And obviously you can retrieve them as well, including the history of it. You can search on them. You can do batch operations, which means actually you're bundling up several REST calls at once and then send them at once. It handles the various formats. JSON and XML are native to the FIRE standard, and there's also binary for the specific resource type binary. which just returns the contents of the resource, like an image. And it can also do validation. So if you're in a scenario where you're testing each other's communication, you can also, or you're not sure where your resources are coming from, Spark can validate for you whether they are correct. What is it? Well, as I saw, we built it to prove that the specification was actually implementable. So it's a reference implementation for DSGU2, and it's built in Microsoft.NET. DSGU2 is the current version of the FHIR standard. The next version will be STU3, and it will be finalized by the end of March this year. It's a standalone generic FHIR REST server, so it does all the resource types and all the defined search parameters. It runs on a MongoDB database, so on a NoSQL database, and it's fairly complete. It's also very monolithic. I will talk about that in the next slide, and we started it in 2012. Well, here is how it works. If you want to use Spark Server, you use it as a whole. You communicate it through the front end, which is through the REST interface, which is defined in the FHIR specification. The FHIR specification defines a create operation, an update operation, and a delete operation. So that's where you can change the resources, and then obviously there's a lot to get them back. Reading, searching history, several more defined operations like constructing a document out of several resources, which you can then parse into an actual document, like a PDF. And also the batch, which can use elements from both of these. That's why it is done this way. Spark has a heavy dependence on how it is coded against the structures in MongoDB. So if you decide to import or extract data directly into the MongoDB database, you are free to do so, but it will be fragile. If the implementation of Spark might change a little, or if you forget one thing, it might not actually work. So that is not recommended. If you want not just a database as a backend, but for example, your own process, because some resources, let's say if you want image resources to come from a PAC server for something very strange, you could plug it in at the backend, but it's not very easy to do. That being said, it has been done. I know of at least one organization that has replaced the MongoDB with several of their own web services, and they host the data from there. So it can be done. It's just that it's not that easy. So what can you do with Spark? Well, the easiest way to get used to it is to use the public server to test a client. I could actually show that to you if you like. This is Postman, which is behaves like a browser, but displays all the results. And here you see the actual URL that I sent to Spark. So if I want to see all the patients that are in there, I'll just ask for /patient, and I receive a bundle back, which is a search at, essentially I'm doing a search for all patients. There are over 5,000 patients, and I get only the first 20 here, and then you'll have to page through the rest. And each entry here is one of the patients. So here is one, and there's the next. If I want one specific one, there's a patient which has the ID of example, easy to remember, then I get exactly that one. So, as I said, everything in FHIR is computable, so you can also check with the FHIR server and also with Spark what it is capable of and what it is not. For that you ask for the conformance statement, which is on this URL. This is just the format we want to retrieve, so it's on the URL metadata, and it tells us that it does all the rest things. It handles resource types, it can read, version read, etc. So if you want to know what a server can do, you can ask it. go back to the presentation. So that's easy. You can just talk to that server. You cannot be certain that your resources are there the next week because it may be reset in the meantime. You can build and deploy your own instance. You can then on-premise or in the cloud. Our own server is running on a virtual machine in Azure, but it does require the .NET platform. You cannot run it on Linux. Here you have a link to the sources if you want to do this. What can you do with Spark? Apart from installing it, you can obviously adapt it. It does require knowledge of Fire and a bit of experience with ASP.NET, the Microsoft Web Framework. But for simple changes like restricting the types of resources you want to accept or add a few search parameters, that is easy being done. You can also have support. There's a Google group, which last bit of here it went wrong, but there's a Google group for Fire.net. There's a Julep chat channel for the whole of Fire, and there's also a specific stream on .NET. And of course, there, if you want to know how Spark works, you can start with the wiki, which is also on GitHub, and you can make issues if you find anything wrong. As I showed you in the slide with the architecture, you cannot, not everything is doable easy with Spark. So you can, but if you want to do more, that is possible, but not with Spark. If you want another database engine, for instance, SQL Server, or you want it run on Linux, or you want to bolt it onto an existing system, or you want a new Fire version, plug in your own components, as I draw it on the picture. Then we offer Vonk to help you out. It's an enterprise-grade successor to Spark. We noted that Spark was used more and more for production scenarios. It was not designed for that, although it does work. But Vonk is designed to do just that. And it comes in multiple configurations, from basic, which is very much like Spark on MongoDB, but also Fidelity, where you can run transactions, or Facade, where it can run on top of your own system. And there are many more deployments methods, like you can deploy it as an application, just like Spark, or in a Docker container, or as a library package to include it in your own software. But I must say, there are free versions of Vonk, but it is not open source anymore. There's a license model on it. So if you have any more ideas, or you're interested in Vonk, you can, or in Spark, no matter what, you can contact us here or on one of the support channels. And I hope you'll enjoy Spark and will use it on the Connectathon, or the Hackathon it is called, on the SIIM 2070. Thank you very much for your attention. And we will now switch to Judy Kichoya.
Hello, everyone. My name is Judy, and I come from a little bit of a different background in that I'm a radiology resident, almost completing with my studies, but I have worked on health informatics and radiology informatics for several years. And it's interesting that we had these 3 talks previously, because mine is sort of like a continuation, and I'm going to talk to you about LibreHealth Radiology Information System. And so I think we already heard about Orthanc, and the other player in this space is DCM Forte when you think about open source PAC system. And then we have several viewers, you know, like Cornerstone, Horus, if you're using a Mac system, and Oasis. And so, but still the focus is still the reading rooms, where in some places like where I come from, Kenya, you'll find a lot of film and whiteboards for reading studies. 1 second. And so sort of what LibreHealth radiology information system seeks to meet is this middle space for the workflow for the radiologist to improve care about, you know, to deliver reports and improve patient care. So that's the gap that we try to meet. And so I'm going to sort of show a quick demo, but the functionality of the system, one is an integrated reporting system. And what we've done is linked to the RAD report, the RSNA standardized reporting templates, where you can import your report template and then be able to use it to generate a report. And then we also provide an order system where you can select a patient. We use coded concepts to enter the testing to be done, and the, you know, an ICD-9 or ICD-10 code for the reason, and then select the agency and who is the person who is ordering the test. And so sort of this is a work in progress, and so that's where we've gotten to. And so we've integrated with an open source medical record system called Libre Health Toolkit, and you can see me searching for a patient name, and you know, you have just the standard people who sort of want to understand more workflow from an EMR point of view, or just want to you know, they're looking for a very simple solution. So you have a radiology tab, and you can add a radiology test. So I can say maybe, you know, lower extremity, right? And so these are all coded concepts, and you can, you know, maybe say that this patient had, you know, trauma, and enter your wherever you want, and you can have it as an emergency. And then I'm just going to be able to show complete so that I can show the rest of the status. But this is more, you know, just a workflow that encompasses not only the ordering doctor, but it's role-based with the person who's acting as a technologist. And so you can see I save the order there. And once, one of the things that we're trying to do is integrate with a viewer. Specifically, we like Cornerstone because it's HTML-based, and most of the places where we use it is in developing countries. They don't have so much, you know, so much bandwidth to maintain multiple systems, and so that's one of our projects that we're working on this year. And so as a radiologist, you know, there are two workflows. You can come and just look at radiology and see all the completed studies, because most of us will never go through the patient view. But what you do is you claim a report, and I'm not using any template here, and so I can just, you know, type my quick reports and, you know, who entered it and complete the report. And so so it's a very simple report documentation system. And one of the things that we're sort of working on now is, you know, to integrate with the viewer, like I said, Cornerstone, and then we had integrated with the PAC system, DCM for check beforehand, but once we started doing the reports, we had to rewrite a lot of our back end, so we disconnected that portion, and we're going to be reconnecting it back using modality worklist. And our preference right now that we're exploring is whether we can just rely on FHIR to sort of be the communication engine between both all the systems involved. And then since we've moved to structured reporting, one of to-dos, which is sort of not the near term for a release, is to just index the JSON objects from the output of the system, and so that sort of you can run an analytics engine based on that. And so the way we're always looking, we're very user-driven, and so we have this link here has all user stories which are collected from real users in Kenya, Malawi, and some places in Latin America. Since the open source projects don't generally always have so many resources, we only build what the user wants, and that's sort of our model. We also have a web server where you can go in and just play around and kind of get a sense of the system. And we're always looking for people who are trying to implement RIS systems or partners that we see. And in our model, we envision that we can have for-profit companies that rely on open source to sort of provide support services for our community. And even as a very basic step, if you haven't sort of ever worked on an open source project, or you're curious what it's all about, you can just go to a link here and just write about yourself and introduce yourself. And sometimes that's always the first step. I found that most people start to sort of follow the conversation. You don't have to be a programmer to get involved. And so if you have more sort of questions, just given the limitations of time, please send me an email or write on Twitter to me, and I'll be happy to respond, and look forward to seeing some of you involved in our project. At this point, we're going to move back to Brad so that we can continue with the question and answer session.
Great. Thank you very much, everybody. So we will now be moving into the Q&A portion of our webinar. During this portion of the webinar, you may ask questions via the chat window at the bottom of the webinar control panel. You can also tweet your thoughts and questions during our live tweet chat, which is going on now using #ImagingIT. So our first question comes from Akram Mohammed to Chris for the OHIF project. Is it possible to embed this OHIF viewer from another GUI web app?
Yes, it is. It has a URL launch interface, and you can also do a deeper integration.
Fantastic. All right. Our second question comes from Jason Nagels to Frederick for Orthanc. What is the impact of dichromatising already large data sets and the a factor impact on the overall size of the stored study?
You're definitely going to duplicate the volume, but once it's been dichromatized, there's no loss of data, so you could just as well decide not to store the original file.
All right, great. Our third question comes from a web viewer for Christian, but I'm actually curious from the whole panel on your thoughts on this. But in specific for the Spark server, is it available as a Docker container?
The Spark server is not available as a Docker container, but that's one reason why we reinvented Spark now as Fonk, because we built the new version on ASP.NET Core, which is the new version of .NET, and that will be able to be containerized in a Docker container.
Okay, great. How about for the other projects? Everyone else on the panel?
For Cornerstone and OHIF. Sorry. Cornerstone is primarily a client-side framework, so it doesn't apply, but the OHIF viewer does have a Meteor component, which is Dockerized, so you can actually spin it up pretty quickly using Docker. The instructions are on the GitHub site.
Okay. Frederick?
Yeah, well, Orthanc is completely Dockerized, so you can use Orthanc, any instance of Orthanc for a specific purpose, and it can thus be used as a microservice, which is which comes in very handy when you just want to use Orthanc for a specific feature. So yeah, it is completely Dockerized.
And Judy? Yes,
LibreHealth RIS is completely Dockerized. If you just go to the repo on GitLab right now, that's what you're using. You can just set up with like 2 commands and you're up and running.
Okay, great. Our fourth question comes from Sylvain Callender for the entire panel. Does your open source projects, are they able to handle integration with other information systems, radiology information systems, or speech recognition systems, such as something like PowerScribe? Judy, we'll start with you.
So our plan is now to integrate with PowerScribe, and we sort of are functioning as the RIS and integrating with PARC systems like Orthanc and the viewers like Cornerstone. And we've not had a problem with that because, they have just Orthanc, like for example, Orthanc, and I mean, I shouldn't speak for Orthanc, but they have a plugin and a form that you can just use to send a modality work list, and that's supported. And using DICOM Web, then it's easy to integrate and view images using Cornerstone. What we envision that most people in the places that we're interested in would not have enough money to pay for PowerScribe licenses. And since we work very closely with academic partnerships, we're going to have one of the students this fall look at integrating, like training Google Voice to just sort of do the reports. But we've just stuck with structured reporting because that's sort of like a low-hanging fruit, and sort of people can still get reports in faster.
Great. Christian?
Well, Spark is all about integration, and so actually you can integrate it with if you send Fire to it. That's so any Fire-enabled system will be able to integrate into Spark. And if it's not Fire-enabled, you can use the Fire.net API if you're a .NET system to make it Fire-enabled. There are also comparable libraries for JavaScript and for Java. So that should be doable to create and consume the resources that you need for your system that can be integrated through the Fire server to make sure that they become available to other systems. That being said, for Vonk, we also envision a scenario where you run a very tiny version of it, which handles all the Fire details to be able to query your system in Fire language.
Frederic?
Yeah, well, if I got the question correctly, it all was about integrating with dictation tools. Orthanc doesn't integrate with any particular dictation tool, as we're not a RIS, we're the DICOM server, and therefore we don't do any dictation integration. We do integrate with all the other systems, so with RIS systems as well, and as such we can basically get the report that was dictated in another system, which is then the RIS. And we also integrate with any EHR over HL7. So yeah, basically it's very easily integratable. However, every RIS has got its way of doing things. So that's really a path we don't really want to go down into. We really want to focus on being the DICOM server, but we can store reports that come from other systems.
Great. And Chris?
Absolutely. The whole point of the OHIP and Cornerstone is about integration, and it supports it at very granular or very fine level detail and macro levels. So you can actually just do a very simple URL launch to launch a whole viewer. You can actually build your own custom web app to display a image in a viewport, and so it'll do everything. Now, obviously, the technology that we're using is web technology. So if the application you want to integrate with is web-based, it's far easier, but certainly possible with anything.
Great.
I maybe quickly want to go back to the fact that, yeah, we can also integrate very easily thanks to the API. It's a REST API, so every feature within Orthanc can be called through this API.
Fantastic. All right. We are out of time for today's session. Unfortunately, if we missed your questions, there are a few more outstanding. Our plans hopefully will reach out and help to answer your questions. So let's close the session up. So we'd like to say thank you once again to AGFA Healthcare for their support of the 2017 SIIM webinar series. And please join us on Thursday, March 16th at 1 p.m. for the next SIIM webinar, Looking Ahead with Pathology Informatics Leadership, an expert enterprise imaging roundtable with a fantastic lineup of pathology clinical panelists in the industry today. So thank you for joining us on today's webinar. Thank you too to all of our panelists today and to SIIM staff for putting this webinar together. All webinars will be archived shortly after the webinar date and made available to SIIM members under the events section of the SIIM website. We will be sending out an email with all the links after the webinar. Please stay on for a moment after the webinar has ended to take a brief survey to evaluate this webinar and help us plan future webinars. Just click on the Close Webinar pop-up to access the online survey. SIIM members are eligible to receive SIIM IIP credits towards ABII certification and recertification. If you would like to receive SIIM IIP credits for your participation in this webinar, please complete the survey and indicate your request to receive IIP credits at the end of the survey. Thank you very much, everybody.